Well, we're being asked to find inverse functions algebraically, and I wanted just to go over a few of these. And I think kind of like what we saw on the composition of functions, um, they try to test our mathematical skills by throwing different kind of weird problems at us. So I'm going to just work about 3 of these, and that way you've got a permanent record that I can put out that you've got on demand that you can go back and look at should you need to. So let's look at this first one. This first one, actually, I'm going to pull from the guided practice in example 2, which is on page 67. This is guided practice number 2A. And we see that we have a function, f of x equals minus 16 plus x cubed. My stylus doesn't want to do right. Okay, so first thing we're going to do is we're going to replace f of x with y. We're going to rewrite this y equals minus 16 plus x cubed. And now we're going to swap our x's and y's. So I'm going to rewrite this again where I got x equals minus 16 plus y cubed. And now we're going to solve for y. So I'm going to first add 16 to both sides. Over here I've got x plus 16 equals y cubed. And of course, now I'm going to get rid of this exponent cubed on y, so I can just isolate the y by itself. I'm going to solve this by taking the cube root of x plus 16 equals y. And then my last step, I'm going to rewrite this whole thing to note that this is an inverse. So I got f minus 1 of x equals the cube root of x plus 16. All right, now I should have said that's after I went ahead and verified first that this right here, this minus 16 plus x cubed is actually an inverse function. Actually, I could look at that and know that because I've got an x cubed here, that it is probably going to have an inverse because there would be a one-to-one relationship. Hopefully, we've talked about that earlier. But anyway, we've now established that the inverse of that is f minus 1 of x equals the cube root of x plus 16. All right, well, let's look at the second one. Again, I'm just picking some out that's going to have us think about our algebraic skills. So here we got f of x equals 4 minus x over x. Okay, now I got a reciprocal function here because everything's over minus x. It's going to pass both the horizontal line test and the vertical line test. So with the horizontal line test, that would tell me that it does in fact have an inverse. So let's solve for that. First step is I'm going to replace f of x with y. I got 4 minus x over y. All right, now I'm going to swap out my x and y's. Let's rewrite this again. So we got x equals 4 minus y over y. Okay, so how am I going to proceed on this one? Well, I'm going to first now multiply both sides by y to clear the y out from the denominator. And that's going to give me xy equals 4 minus y. And let's see, we don't want to run out of room. Let's just take this up here. So now I'm going to add y to both sides. So I've got xy plus y equals 4. And I can factor out a y from this left side of the equation right here. Right here. So let's do that. And I'm going to go y parentheses x plus 1 equals 4. Now I can divide both sides of the equation by x plus 1. That will leave me with y equals 4 over x plus 1. And last step, rewrite this thing as an inverse. F minus 1 of x equals 4 over x plus 1. So the equation f of x right here equals 4 minus x over x has an inverse, and that inverse is 4 over x plus 1. Solve inverses algebraically. All right, let's look at this last one. Here we got f of x equals 7 over, well, let's just really complicate it. 7 over the square root of x plus 3. Now I can go ahead and graph this 7 over the square root of x plus 3. I could then see that it is, in fact, does pass both the vertical line test and the horizontal line test. Not only is it a reciprocal function, but it is a square root function in the denominator. We have all kinds of little things to complicate this with. But let's move forward. First off, we're going to replace f of x with y. So y equals 7 over the square root of x plus 3. Now let's swap out our x and y. So now we got x equals 7 over the square root of y plus 3. Okay, so what do we do? What do we do? Well, let's multiply both sides of the equation by this square root of y plus 3. So now I have x times the square root of y plus 3 equals 7. Let's move it up here so we can continue to see what we're going to do. All right, so I'm going to now divide. I'm going to get rid of this x from the left-hand side, and I'm going to divide x to both sides. That's going to give me the square root of y plus 3 equals 7 over x. So I got to get rid of this square root. Well, I can square both sides of the equation. So I can go square root of y plus 3 squared equals 7 over x squared. When I square the square root of y plus 3, of course, I'm just going to have y plus 3. And when I square 7 over x, I'm going to have 49 over x squared. Now I can subtract 3 from both sides. Y equals minus 3 plus 49 over x squared. And that actually is my inverse function. So let's take the last step here and let's rewrite this. F minus 1 of x equals minus 3 plus 49 over x squared. Are we having fun yet?